Alright guys, today what we're going to do is the last way that we are going to use to solve a system of equations. We've already talked about graphing in your first unit. We talked about substitution yesterday. Now we're going to go on to elimination, which is also known as linear combination. Now again, the solution is still the same. This is still where the two lines intersect, or three, or however many. Okay. Now what's different about this is usually how it's presented to you. Elimination is usually presented in what we call standard form. Right? The ax plus by is equal to c. A, b, and c are integers, and x and y stand for the coordinate. Right? So we have some examples down here. You can take a look at it if you'd like. Now, again, today, you need to have your own notes. You guys are going to be copying this down for yourself. All right? If you need to pause to copy something down, feel free to. All that good stuff. Okay? All right. So let's get started. Now with elimination, this is nothing new. You guys have done elimination before, and in fact I think this is usually the way most of you prefer to do it. Now I'm going to show you kind of how I think about elimination and kind of the three different methods during elimination that you can use. There's usually a process to go through an elimination, right? The idea of elimination is you are eliminating a variable. You're trying to get just a variable by itself. Right? It's kind of the same idea as substitution. It's just how we get there. We still can't solve an equation with two different variables, so we got to get down to one. Now, the nice thing about system of equations is we know that the x and y values are the same in each. All right? If that's true, then we can actually combine like terms in those two equations to create one new equation. Now, what we're trying to do with this is that, for example, in the problem we have here, it's already in standard form that ax plus by is equal to c. The x's are lined up, the y's are lined up. We have the equal sign, and then we have the solution on the other side. What I like to do is put a line underneath. My first step always is to look at the equations, and if I can combine like terms right now and eliminate one of the variables, in other words, make it 0, I'm already on the right track. So for example, in this problem, I have 1x plus 3x gives me 4x. 2y minus 2y is actually 0y. It's gone. Okay? And 7 and a negative 3 is 4. Okay? So what I've done here is I've actually eliminated the y value. Once I've done that, if you notice, I'm now down to one type of variable. It's the x. And I can solve that. And again, it won't be hard. 5 by 4, you'll get x is equal to 1. What that tells you is you now have the x coordinate. Now, this is going to be slightly tougher than yesterday, but the idea is still going to be the same. Once you know what x is, you're not going to put just an x anymore. You're going to put its value. So instead of writing an x, I'm going to use this first equation as an example. I'm going to plug in a 1. So I got 1 plus 2y is equal to 7. At this point, what's going to make this a little bit tougher is that you're actually going to have to do a little more solving. Add negative 1 to both sides. 7 minus 1 is 6. Divide both sides by 2 to get y by itself. And now I have y. Okay? So these two lines are going to intersect at the point 1, 3. Okay? Alright, let's try another one. Now, a couple things in this problem. And this is going to go kind of on the second progression in solving a system of equations. Now, to start off with, this is not, the second equation is not in the correct form. So not in the correct form, we're going to have to put it in the correct form. And the idea is that you want ax plus by is equal to c. Well, this x is on the wrong side, so I'm going to add the opposite of that 10x to both sides. All right, so now those go away. So I'm going to end up with this. I'm going to write the first equation first. Okay. Then the second equation now will be a 10x plus 3y and then equals 13. Now I have everything lined up correctly. You just can't move the negative 10x over. You actually have to add the opposite. Make sure you know that's clear. All right, so here comes the next part. When you're looking at this, if you try to add right now, if we add right now, we're going to get 20x, negative y, and 19. That does not eliminate a variable. That negative y is not 0. All right, so that produces a problem. So here comes the second step in this process. The second step in this process is to look. is there a variable that has the same coefficient? In other words, the same number in front of it. You do, the x. If you have this situation, what you can do is make one of them the opposite sign. And when you do that, you are basically multiplying it by a -1. Okay? Now, you can do the top row, you can do the bottom row. It doesn't matter which one. I always usually just choose the bottom row. I'm going to rewrite the first equation. So the 10x minus 4y is equal to 6. And now I'm going to multiply the second equation by -1. When I do that, that 10x becomes a negative 10x. 3y is negative 3y, and that 13 is now a negative 13. The reason why I do that is because now 10x minus 10x gives me 0x. So I've now eliminated the x. 4y minus 3y is negative 7y, and then negative 13 and 6 is negative 7. So the x is gone. I can divide both sides by -7, and I know now that y is going to be 1. All right. Now, with that in mind, I still have to find x. Now, when I do this, I actually, a lot of times, I like to use the original equations, all right, even from what we did earlier. You'll see that later on in some of the other problems we do. So I'm going to take that one, and I'm going to substitute it in. For this one, I'm going to use the first equation again. If you want to use the second, feel free to. And I'm going to write 10x minus 4 times 1, which won't be hard, is equal to 6. Okay, well, you got 10x, negative 4 times 1 is -4, equal to 6. All right, it's a 6, not a -6. There we go. All right, from here, add 4 to both sides. 10x, sorry guys, pen's taking a little bit of time on me, equal to 10. Divide both sides by 10. X equals 1. So if I were to graph these two lines, they would cross at the intersection point of 1, 1. All right, next one. All right, so this one might be slightly new, but I want to make sure to make this as easy as possible. So now we've added a fraction in here. Don't make this hard. All right, if we're adding a fraction in here, we get rid of the fraction. Now I'm going to give you a hint on this. We don't want to solve problems with fractions in them. All right, nobody likes fractions. Get rid of them. So I'm not going to do anything to the first equation. I'm going to leave it as 4x minus y equals 6. What I am going to do is I'm going to change the second equation. I'm going to change that by getting rid of the fraction. The way to get rid of the fraction is to multiply the whole thing by the largest denominator. Well, the largest denominator there is 3. So that means I'm going to multiply everything in this equation by 3, both sides. X times 3 is 3x. 3 times 2/3 is actually 2. So you get 2y. And 7 times 3 is 21. Okay? So that is how I get rid of a fraction. Okay? At this point, we are now going to go on to the third step. All right? The third step in this progression, if we look at the first one, if we add right now, you want to eliminate a variable. You end up with 7y plus y. That doesn't work. If you look, there isn't a variable in each term that has the same number. You get a 4 and a 3 and then a -1 and a 2. That doesn't work. So now we go on to manipulating the equations using multiplication. All right? So here's what's happened. At this point, this really becomes up to you. It's your choice. You choose a variable you want to eliminate. Whether you want to eliminate x, you eliminate y. Now, there are some shortcuts here, and over time, and from what you've learned in the past, you can make this simpler. What I do is I look at each one, and I look for the least common multiple. All right? In other words, the smallest number that is the multiple of each of those. Between 4 and 3, the least common multiple is 12. All right? Now, neither of those are 12, so that means I got to change both of them. Over here, my least common multiples of 1, between 1 and 2 is 2. Well, this one's already a 2. The second one's already a 2. So that means I only have to change the first one. That's one hint. The other is to look at the signs. I always try to look for opposite signs. Anytime I have opposite signs, that means I'm not multiplying by negative numbers. Okay? That's just my choice. In this problem, if I was going to eliminate a variable, I would eliminate y. In other words, I want to make that y 0. I know that the least common multiple between between 1 and 2 is 2. Well, the second equation already has a 2y in it. So I'm not going to change the second equation. That's going to stay the same. To get 0y, that means this negative 1y has to become a negative 2y. So what do you have to multiply negative 1 by to get negative 2? Well, you multiply it by 2. So that's how you're going to change this second equation, or so the first equation. You're going to change the first equation by multiplying it by 2, and that means everything by 2. 2 times 4 gives me 8, so I get 8x. 2 times the negative 1y will give me negative 2y. The 6 times 2 is 12. From here, now if I add, I will now eliminate a variable. I'll eliminate y. So I end up with 11x, 0y equals 33. This y is gone. If I divide both sides by 11, I now know x is going to give me 3. Alright, so now, with that in mind, same idea as before and what you've done already. Once I know what the value is of x, I'm just plugging 3 in for x. Now, again, it's up to you on which one you choose. My guess is because of the fraction, the majority of you would choose the first one. So you're going to do 4 times x, which is now a 3, minus y is equal to 6. So that's terrible. Let's try this again. 6. There we go. 4 times 3 is 12, minus y is equal to 6. Add negative 12 to both sides. You get negative y is equal to negative 6. And divide both sides by negative 1. You now have a y coordinate of 6. Alright. Next one. Alright, so I always like to show this one, and on this one I'm only going to show the first step on how you would eliminate. You guys can go through and solve it yourself, and I'm trying to save you guys some time. When you look at this one here, again, first step, is it in standard form? It is. Okay, so we got that. So in that first step, if I try to add right now, would I eliminate a variable? No, I'd end up with 2x and 10y. Second thing I look at is, do I have the same coefficient in front of x or y? No. So at this point, you're going on to the third step. This third step deals with now choosing a variable you want to eliminate. Right? And really on this one, it doesn't really matter. They're both equally the same level of hardness. But so what I'm going to look at is I'm going to look at their values. So the least common multiple for x would be 12. For 3 and 7 for the y is going to be 21. Well, for me, I'm going to choose the x. The reason why I'm choosing this one is because of the opposite sides. That's the only reason. All right? Doesn't make it that much easier, but it makes it slightly easier. So I'm telling myself that I want to make x 0. So I know in this one, since the least common multiple is 12, and that first one's already positive, I know I want to make that a 12x. Second equation, that's already negative, I know I need to make it a negative 12x, so that'll be 0. So what are you going to multiply 6 by to get 12 in that first equation? You're going to multiply it by 2. That means everything by 2. When you get that, you get 12x, all right, plus 6y is equal to, in this case, 54. Okay? In the second equation, no. In this case, what are you going to multiply negative 4 by to get 12? You're going to multiply it by 3. I'm going to multiply the second equation by 3. Okay? So with that in mind, 3 times negative 4x is negative 12x. 3 times 7 is going to be 21. Sorry, so 1. So you get that 21y. And then you got 27 times 3, which will be 81. Alright, so from there, we add straight down. The 12x and the negative 12x is 0. 6y plus 21y is 27y. And then you get 54 plus 81, which is 135. Okay, so you've eliminated the x. From here, you divide, and you can go on and finish the rest of that problem. But I want you to see what happens when you have to manipulate both equations. Okay? If you have more questions about that one, ask me about it tomorrow. Okay? Because I need to go on to this next one. All right. So, as we did before, we had 2 by 2s for all those. So for each one of those, we had 2 equations and 2 unknowns. All right, well, this is where the fun starts. Now we're talking about 3 equations, 3 unknowns. So, how we want to solve this and how you want to go about this, there's a lot of different ways. There are about 10 different ways that you could go about this problem. I'm going to show you one right now. Here's the thing. You guys can't solve for x, y, and z the way it looks, okay? What you've been taught and what I think you're more comfortable with is solving a system of equations with just 2 variables in it, okay? So what we're going to do is between these 3 equations is we're going to create a system with just 2 variables in it. And from there, you're going to take what you've just learned and apply it to those, and then we'll finish the problem from there. Now, for this problem, start off with, what I'm going to try to do with this problem is I'm going to try to eliminate x, okay? I'm eliminating x. So when I write my 2 new equations, they're going to have a y and a z in it, okay? Now, how you do this, there's a lot of different ways. What I did is I started off to begin with the first 2 equations. The second 2 equations. What I'm going to do to start with is if I want to eliminate x here, since they have the same coefficient, I need to make one of these negative. So what I did in this problem, all right, you're going to say I'm going to do some erasing in this one eventually. I basically took that second equation and the third equation and multiplied it by -1. So I end up with a negative x, a negative 3y, and then a negative 3z. Okay? And then over here, the 19 becomes negative. Okay? From here, when I add, the x's go away, end up with negative 1y, negative 2z, then negative 8. Okay? That is one of my equations. I'm going to put it right down here. Negative y minus 2z, sorry guys, equals negative 8. Equals negative 8. Sorry. Okay? So that's from that first one. Okay? So now, with that in mind, I need to choose 2 different equations. I can't use 2 and 3 again. I can do 1 and 2 or 1 and 3. Okay? And for this one, I'm going to choose I'm going to choose 1 and 2. All right? So I'm going to take these 2 right here. All right? Now, here's the thing. When I look at this, a lot of you guys will want to try, well, I can eliminate z. That'll be easy. Doesn't do us any good. If you eliminate z, that doesn't match up over here. You need a y and a z in this one. So you're trying again to get rid of x. So in this one, I'm going to do it right here. I'll do it right next to it. I'll do it over here. I'll do it in red. Between the 2 and the 1, the least common multiple is 2. So the first one is going to stay the same. Now, here's the thing. I want to make this 0. Well, to make it 0, what I need to do, what do you got to multiply x by to get, what does this need to be in here? This needs to be a negative 2x. What are you going to multiply x by to get that? You're going to multiply it by negative 2. Okay? Negative 2 times x is negative 2x. Negative 2 times 2y is negative 4y. Negative 2 times z is negative 2z. And negative 2 times 11 is negative 22. With that in mind, I'm going to add straight down. I get rid of the x. Then with negative 3y, negative z, and then 13 minus 22 is negative 9. So that's gone. My second equation now is negative 3y minus z equals negative 9. All right, so from here, it's really up to you on how you want to go. But now you have two equations with two unknowns. Well, you're basically going to take what we just learned and you're going to apply it to this. Okay? And how you do the next step is really up to you, which one you want to eliminate, but I'm going to eliminate z. So for this one, if I know I want to eliminate z, I want to make that 0. Okay? So least common multiple between 2 and 1 is 2. Well, since the first equation already has a 2 in it, -2, I'm not going to mess with it. I'm going to leave it alone. But I do know that I want this one to get 0. This has to become a positive 2z. Okay? So what are you going to multiply -z by? -2. So -2 times -3y is 6y. -2 times -z gives me the 2 that I want. Then -2 times 19 is 18. -y plus 6 is 5y. So I'm adding right now. Get plus minus 0, z, which will go away, is equal to 10. So at this point, I have now divided both sides by 5. I find that y is going to be 2. So I'm now have found y. Right? Now, just like before, using this system, once you know what y is, you can plug it back in. In fact, I'm going to plug it into the second equation. I'm going to write, move this down a little bit for you guys, -y, which would be -2, goodness gracious, minus 2z equals -8. Well, add 2 to both sides. Why this is doing this? It's taking forever. 2z is equal to -2z is equal to -2z is equal to -6. There we go, that's better. Divide by -2. We now have z. Z is now a 3. So we now have z. So now we have y. Now we have z. Now with that in mind, you can take those, and if you notice, you can actually plug that 2 and that 3 into any one of these equations for z, y and z, to solve for x. Now again, it's really up to you. I'm going to plug it into the first one, just for the heck of it. In fact, I'm going to do it right above it. Ready? So I'm going to do this in red. This might make it easier for you guys. 2x plus y, which is now a 2, plus z, which is now a 3, is equal to 13. Now, 2 plus 3 is 5, so you get 2x plus 5 equals 13. Add -5 to both sides, you get 2x is equal to 8. And then from there, you get x is equal to 4. So you get a 4, a 2, and a 3. Yeah, hope everybody understands that. If you got any questions about that, ask me about that one tomorrow. I want to do one more. Okay? Here's why I want to do this one. When you look at this one, the big idea here is that, if you should notice, again, it's going to be very similar to the one we just did. But here's a big point I want to make sure you guys remember. This one already is missing a variable. That one's already missing a variable. That means you basically already have one that already has 2 variables in it, so you basically have half of it done already. Which means from here, what you need to do is find a way to eliminate, in this case, since we have x and y, eliminate z in the first equation, in the second equation so that you can get an equation with just x and y in it. So I'm going to write both of those down here. X minus y minus 2z equals negative 6. And you got negative 4x plus y minus z equals 12. So if I'm looking at this, starting off with these common multiples are going to be 2. So the first equation is not going to be changed. Leave that one alone. And I know I want to eliminate z, so I know I need a 2z here. So if I know I need a positive 2z, that means I'm going to multiply this whole equation here by a negative 2. So negative 2 times negative 4 gives me negative 8x. Negative 2 times negative positive y gives me negative 2y. There's my 2z. And then from there, on the next part, if I'm doing 12 times negative 2, that's going to give me a negative 24. Okay? All right, so go to eliminate from here. Oops, that's supposed to be a positive 8. I apologize. So you got x plus 8 gives you 9x. Negative y, negative 2y is negative 3y. And then you've got plus 0z. So that's going to be gone. And negative 6 and negative 24 is negative 30. So what you have left here is you have a 9x minus 3y is equal to negative 30. Right. Now, how you want to do the next part is completely up to you. Right. If I were doing this, I would actually eliminate x. That would be my choice in this problem. So I would have to change the first one. So I want to change that to make this again, to make this 0x. I'm going to multiply the least common multiples are going to be 9. Least common multiples 9. That means the second one already is the 9x that we want. Okay? So I'm not changing that. So what that means is I want a negative 9x here. If I want a negative 9x there, that means I need to multiply this whole thing by negative 3 times 3 gives me negative 9. From there, I'm going to get a negative 6y, and then negative 3 times negative 25 is 75. Add straight down, I'm going to get the 0x that I want, negative 9y, and 75 minus 30 is 45. X goes away, and I get negative 9. Divide both sides by that negative 9. And I get y is equal to negative 5. Okay. So at this point, I know what y is again. It's negative 5. Alright. And then if I go back, I'm going to plug that into one of the two equations. I'm probably going to plug it into the first one. So I will have 3x plus 2 times negative 5 equals negative 25. So I get 3x minus 10, because 2 times negative 5 is negative 10, equals negative 25. Okay? Add 10 to both sides. Sorry about the writing. This thing's acting weird on me again. Add 10 to both sides. Ugh. There we go. 0, so you get 3x. Negative 25 plus 10 is negative 15. Divide both sides by 3. And for x, I also get negative 5. So in this problem, I get an x that's negative 5. I get a y that's negative 5. And from here, if I take a look, I can plug in these two and then just solve for z. Okay? So, if you take a look at this, I'm going to write it down here. So, I'm going to write negative 5 for x. I'm going to write plus 5 for the opposite of negative 5. Minus 2z equal to negative 6. No? Look what happens. 5 cancel out. You end up with just negative 2z equals negative 6. Divide by negative 2. You get z to be 3. Ta-da! Alright, so from there, you have the point. Oh, that was terrible. Negative 5. Negative 5. And hopefully I can write it. There we go. And 3. Okay? Alright, ladies and gentlemen, we will work on this tomorrow. Ask any questions about these problems if you got any. Alright, talk to you later.